all these questions. I know it's a lot to take in at once, but let's do our best.
Well, it is toxic. There is no debate about it. Dispersants are made up of two primary components. One is an organic solvent, and the other is a detergent or a soap. And so they perform two tasks. As far as the oil, it has an ability to actively almost act like a dissolving character of it. It breaks it apart into smaller and smaller size components. So that's the solvent aspect of it. The detergent aspect of it, I think we're all familiar with, can bind it and actually remove it and make it much more soluble-like. So the dispersants have it, from the oil point of view, have the ability to break it up into smaller components. But in the subsurface, that's a whole different story. A lot of this, we don't know what's going on in the subsurface. Again, the idea that under 2,000 psi at the bottom of the ocean, they're shooting in streams of dispersants that have never been tested at those depths, at those pressures, the kind of chemical interactions that could occur with those changes in pressures, with those changes in temperatures, quite unpredictable. The relative ratio of oil to dispersant was relatively high. And because the dispersant has the capability of actually dissolving, not staying insoluble in water, or a particle, but actually dissolving, it is much, much more difficult to find. Also, it's extremely surface reactive. So when you capture it in a glass vial, you can test the water and it comes out perfectly clean, and it's all attached to the side of the glass vial. So testing this stuff is like, that needle is getting thinner and thinner and thinner in terms of the impact. So why would you do something like this? And I think the idea is, it's what you know, and you want to preserve versus taking the step of perhaps altering what you don't know. As a scientist, of course, I feel kind of strongly that rather than destroy what you don't know, which is the potential of incredible resource, and I mean it on the medical side, I can mean it in numbers of ways, it seems unnatural that you would risk losing something that you don't have a clear understanding of at the expense of perhaps saving something that you might be able to. And again, as Bob has emphasized, if they did not use the dispersants, perhaps more oil would come to the surface. But I think there's a lot of physical chemists out there that say the subsurface oil was destined.
So what I'm going to do is address the portion of the question that deals with, can we harvest that subsurface oil? And the answer really, I think, is no. Again, David uses very sophisticated equipment, mass specs. I still think the back of the envelope is the most important scientific device. So if you take the volume of oil that is said to have been spilled, and look at the distance over which that oil may have been distributed, multiplied by 300 meters or whatever you like out of the figures that David showed, you come up with a volume of ocean water that this stuff was distributed across. And when you divide one by the other, you come up with parts per billion as the concentration. So there's no surprise that what was found looked like clear water. And I doubt that there are big pockets of collectible oil anywhere. It's in very low concentrations.
There were several questions that we don't have the expertise to answer involving public health effects on humans, and whether or not, why we used Corexit here when it's banned in other countries. The Corexit, detection to the Corexit directly, as you saw Dr. Hollander go through all these steps to just determine whether or not it was BP oil, detecting the Corexit, which is actually a very, very small volumetric percentage of the total mixture. It's just a fraction of the volume of the oil that was out there. It's probably more important in the way it changed the physical properties, changing the oil to a more water-soluble phase that can become more biologically dangerous. But with that said, generally speaking, fish, for example, can get rid of hydrocarbons. They excrete them through their digestive system. So you don't have the classic, speaking as a whole about all of the hydrocarbons, including the peroxide, you don't have the classic bioaccumulation that a lot of people are afraid of. There may be certain compounds within that mixture that accumulate, but by and large, the hydrocarbons only accumulate if they're ingested or taken up at a rate faster than they can be excreted. Because fish in particular have a very effective way of getting rid of the hydrocarbon.
Okay, thank you. Thank you. Testing.
1, 2.
We have 10 minutes left in the Q&A before we bring the next panel. So we're going to ask you to respond quickly to the next set of questions. These questions, we have 2 questions for Dr. Peebles. And so they're somewhat related. First one is, National Geographic reported that on May 4th, Duffin Island Sea Lab reported normal amounts of plankton. On June 2nd, only 40% of the first sampling, and on June 28th, 10%. And this person asked, how can you say you don't know effects? I'm just reading the question. And the second question is then, from another person, was the recorded loss of marine life worse or better than you expected?
The plankton effects are hard to detect just because of the size of the animals and the effort required. But we saw clearly there were certain organisms that are part of the plankton community that are larger that were killed outright in mass numbers. No question about it. Surface-dwelling varieties of jellyfishes and other animals that don't have common names were killed in vast numbers. Inherently, whenever you're looking for trends in the numbers of animals in something like plankton, you've got so much natural variability over space and time that it's very hard to pick out a response unless it's catastrophic. So we saw direct evidence of mortality in the larger animals. It's very hard to assign mortality or lower numbers to an event over space and time just because of natural variation.
What a bullshit answer. Okay. Let's move on to, we had a lot of questions about how far the oil actually went, and this one is a bit of a two-parter here from a 5th grade student with us. How did the turbidity affect fish, and how many meters did the oil spill go to, essentially how far? After the blowout, there was major forecasting that the oil would travel around Florida and up the East Coast. What happened to those predictions? Were they true? Of the 26% still at sea, how far has BP oil dispersed south toward the Tampa Bay area?